guys, I welcome you all to our channel CSNet Lectures. So in this session, we are going to start with the discussion of heap trees as I said in the last videos, right? So what is a heap tree? So here we are going to discuss very important points that is which may be asked in examination point of view or in theoretical manner, right? So those points we are going to discuss are not in elaborative way, so that you can easily remember, friends, right? So what is a heap tree? So it is also called as a complete binary tree. So what is a complete binary tree? So binary tree is nothing but it is going to have two children or one children or no children. So what is meaning of complete binary tree? So it is going to have the two children present for the respective node. So that is called as a complete binary tree. So that we are going to follow it over here. Okay, so what all is important applications of this heap tree? So the applications are, it is predominantly used in construction of priority queues. That is, we are going to give priorities for processors in order to get allotted to the resources. So in that case, heap tree constructions, that is called as heap sorting. So that we are going to use as one of the major applications of construction of heap tree. The next important application is, just now I told, heap sorting. So in future videos, friends, I am going to discuss about different types of sorting techniques that we are going to use for arranging the data elements in some ascending order or in descending order. So in that case, heap tree is playing a major role, so which is called by another word as heap sorting. Okay, friends, so that is going to be covered in this construction. Then another important application is in Dijkstra's algorithm. Okay, so what is Dijkstra's algorithm? We will be using to find the shortest path that is being lying between the source and destination. So in order to find that shortest path, we are using this heap trees as the major role for construction of the data structure. Okay, friends, so these are all very important applications, friends. So you must have to make a note of it. Then heap tree can be constructed in two ways. So one we call it as min heap and another one is called as a max heap. Then another speciality of this heap tree is, it is called as a structured order property, or it is also called as a level order property. Why we are calling in that name is, while constructing the heap tree, the root node will be either having the maximum value when compared to that of the children, or it will be having the minimum value compared to that of the children. Suppose if the root node is having the maximum value when compared to that of the children, it is called as max heap. Then another word what we are going to refer is, it is also called as the descending heap, because larger value, right? Then if the root node is having the smaller value when compared to that of the children, then it is also called as min heap, or we can also call it as an ascending heap. Okay, friends, so now in this session I am going to teach you on how to use max heap construction. Just now I discussed all these important properties, so please make a note of it. In examination point of view, these are all the questions that they may ask. So now we are going to see some problematic explanation of constructing max heap. Okay, suppose if you are understanding this max heap construction, friends, it is really very easy. Okay, so if you would have understood this max heap construction, we can also easily construct min heap, because the placement of root node is going to show you the differentiation. Okay, friends, so now we will see max heap. Okay, so now I will be telling you what are all the different types of questions that you may get in this heap data structure is. They will give you some data structure, that is heap tree, that is binary trees. So in that you must have to find which is having a valid heap construction, or they will give you some set of data elements. So in the data elements you must have to construct the heap tree. Okay, then they will ask you questions on heap sorting, that is number of reheapings. Okay, number of alterations that is needed. So all these types of questions we are going to discuss in one problem. Okay, so now without any delay I am going to start this problematic explanation. So friends, I request you to subscribe this channel and share to many of the students, so they will watch and they will be getting a clarity on this data structures topics. So please do this for our team members, friends, right? So now we will move on to the discussion. So friends, this is the given problem. So now I am going to construct a valid heap data structure for max heap. So what is max heap? In each and every level, the root node value will be maximum when compared to that of the children. So based on that, we are going to start. Yes, shall we do? Okay. So what is the first element present? So it is 41. So since there is no more data structure present, since this is the first element, I am going to take it as the root node. So make it as root node. So it is 41. I have finished. What is the next value? So please follow, then only you will be able to understand. So what is the next element? The next element is 150. So now if you see friends, in each and every element insertion, I must have to check for all the levels. Okay. So root node should be maximum when compared to the children. That you must have to keep in mind. So 150 is greater than the root node. Can I leave like this? No, we cannot leave. I should have to do the alteration in order to make the root node should be the maximum value. Okay. So I must have to do a simple alteration, that is 150 should be moved over here. Okay friends, 150 should be moved over here and 41 should be placed here. Now if you just see 150 is maximum value, that is root node is maximum. So now this is correct. So one alteration I have made. Okay friends, so let me make a note. So one alteration, 1. Right. So now what is the next value? Next value is 60. How should I have to insert this 60? See, after filling the left children only, I should have to move to the right node. This is the procedure. Left, right. Again, the same thing you should have to follow in all the constructions. So 60. Now I am going to insert over here. Please note what are all the important points that I am just telling you. It is it will be really very useful while constructing the structure friends, right? So now if you check, when compared to that of the root node, 41 and 60 are lesser. So it is satisfying the condition. So leave it. So next you take 90. So 90 I am going to insert over here friends, right? Because this is being filled, I am going to move on to the next level. So here left, right, like this I should have to fill. So 90 is more, that is it is having greater value when compared to that of the 41. So what I should have to do? I should have to make the alteration, isn't it? So 41 should have to be moved down and 90 must have to be moved upward. So this type of alterations what I am doing is also called as reheaping. Make a note. So just to make the alter. So what will happen? 90 will be coming here friends, right? Then 41 is going to come over here. So now if you check 150, once again it is greater than the children. Again 90 is greater than this children. Can you follow? So this is being completed. So next is 30. So what is the alteration that I have done? Only one alteration, that is second reheaping, second alteration. So use as 2. Next value is 20. So here only I should have to insert, isn't it? So insert and see 20. Check for the condition. So 20 is lesser than 90. So this is satisfied. No need to do any alteration. So keep it as it is friends, right? So next is 100. Okay, so where I should have to insert? Here only. So insert here as 100 friends. So now if you check, 100 is greater than 60. I cannot leave it as it is. So I should have to make the alteration in order to satisfy this max heap structure. So 100 will come here. Okay, then 60 will be moving over to this area, right? Can you follow? So again you check, 100 is once again lesser than 150. So no need of doing the further alteration in the upper level. So I have done the third alteration. Okay. So what is next value? So next value is 28. So where I should have to insert? Here 28. So once again you check whether the root node is maximum or minimum. So 28 is lesser and root node is maximum. So no need of doing any alteration. Okay friends, now if you see in each and every level, the root node is holding the maximum value when compared to that of this children. Okay, so I can tell that this is a valid max heap data structure. Okay, so like this you must have to construct. So for example, if another two elements are coming, for example let it be 200. This is another one element is coming. So how I will be inserting it? So here only I should have to insert. Okay. So according to this question, the total number of reheaps that I have made for making this data structure as a max heap 1, it is 3. Number of reheaps is 3. Can you follow? So now this is in valid heap construction. Okay. So now 200 is coming. So where I should have to insert? Here. Like this, they may ask you some question. They will be giving you some data elements. Insert and show the element 200 in this structure. How you will insert? You should have to start over here. So here 200. Can you follow? So if I am inserting 200 over here, is this right? So I must have to do the alteration. Okay friends. So what will happen? 200 is greater than this 41. So I cannot leave as it is. So put 200 over here. Okay. Then 41 over here. Can you follow? So again you see 200 is greater than the root node. I cannot leave as it is. See, one reheaping I have done. So 90 is going to come over here. Can you follow? Right. So 200. So another reheap I have done. So 200 is again greater than this root node. Can you follow? See, move from bottom to top and check each and every level in order to make that respective root node as greater. Again it is greater than the root node. So make the reheap. So 200 will come here and 150 will be lying over here friends, right? So if you see this whole data structure, this root node in all the levels are greater. Okay. So total number of reheapings here also it is going to be 3. Friends, are you all clear? So this type of construction is called as heap tree construction. Now another important point is, if they are asking you to delete one element. Okay, for example, I want to delete an element 100. Please make a note. If I am going to delete this element 100, what is the final data structure? Okay, so that I must have to see. Okay, so this is another very important question. So how I will be deleting this? See, please make a note of it. This is my element to be inserted, I mean deleted. So the step 1 is replace the data element what I must have to delete with the last node in this data structure. So here, which is the last element according to this level? 41 is my last level. So replace this 100 here, okay friends, and 41 in this location. So this is my first step. Can you follow? So now second step is this 100 is going to get deleted. Okay, so I am going to delete this data element 100. It is not present. Now I should have to check whether this altered data structure is in max heap rules. You just view and see. So in this location, so there is some problem, isn't it? So I must have to do the reheaping. So after deleting this 100, okay, what will be the valid heap data structure after making this alteration? That I must have to find it. So here if you see, 41 is greater than this 60. That is, this root node is minimum when compared to that of the children, right? So make the alteration simple, okay. So 60 will come over here and 41 is going to be here. So this is your final data structure after deleting the element 100 friends, right? What you should have to do, suppose if they ask this type of question is step 1, interchange the deleting element with that of the last node value, then do the reheaping. Then find the total number of reheaps. So here, what is the total number of reheaping? It is 1. Can you follow friends? So that's it. So like this only you must have to construct heap trees. Okay. So how heap sorting is playing here the role is, if I am going to arrange the elements, for example, these are the set of elements, I want to use heap sort method for arranging the elements either in ascending order or in descending order. If I use heap sort, if I want to arrange the elements in descending order, I can use this max heap. Okay, so this root node element will be removed from one by one by using this deletion, what I just told. Okay, just keep it in mind. If I want to arrange the elements in ascending order from the random set of elements given, use this heap tree construction. Since it is ascending order, I should have to use min heap. Okay, so remove the smallest values that is being present in the root node. That's all. So once you remove, your element is going to be in sorted order. Okay, so they will ask you some of the questions, that is number of reheaps, what is a valid heap, if I am going to delete one element, what is the final data structure, okay, or construct min heap or max heap and so on. So friends, in this session we have discussed about heap tree constructions of max heap. Now what you should have to do is, I am going to give you a work, that is, this is my given set of elements, take only this one, use min heap, okay, use min heap and put the data structure, and you tell me in the comment section whether you have got this valid heap data structure, that is it possible for you to do this construction for min heap. Okay, so based on your comment, I am going to explain you the min heap also, friends, right? So this is a very important session. I request you to share this to all the students, so they will be getting benefited. So we are going to meet in the next video with that of types of binary trees, friends, right? So we will meet there. So bye and thank you.